Colloid shows some unique properties like Tyndall effect, Brownian movement, electrophoresis, coagulation, and adsorption. The Tyndall effect is the phenomenon in which the particles in a colloid scatter the beams of light that are directed at them. This effect is exhibited by all colloidal solutions and some very fine suspensions. So, it can be used to verify if a given solution is a colloid. The intensity of scattered light depends on the density of the colloid particles as well as the frequency of the incident light. When a beam of light passes through the colloidal particles present in the solution do not allow the beam to completely pass through. The light collides with the colloidal particles and is scattered, meaning that it deviates from its normal trajectory, which is a straight line. The Tyndall effect will increase linearly with concentration. The colloidal particles in solution are in a state of constant and rapid zigzag motion called Brownian movement. It is resulted from a random collision with the molecules of the suspending medium, other particles, and the wall of the containing vessel. The higher the temperature, the more vigorous is the movement of the molecules. Another unique property of colloid is electrophoresis. The particle of colloidal solution possesses either positive or negative charge. If a colloid solution is placed in a U-tube and potential difference applied at its two ends, the charged particles are seen to move towards the opposite electrode. This movement of the charged particles under the influence of an electric field is known as electrophoresis. Coagulation. Addition of electrolytes cause the precipitation of the colloidal particles coagulate because the charged ion of the electrolyte neutralize the charge on colloidal particles. For adsorption, it is a process involving bulk penetration of gas or liquid into the structure of the solid, which is usually associated with an increase in the bulk volume. What do you understand with surface chemistry? So it is a chemistry on surface of something. Something here can be anything. Let's take one example. We have iron rod here. Okay, on top of the iron rod, there are one layer of particles deposited on the surface of the iron rod. So this particle is called rust, or the chemical name is hydrated ferric oxide. So rust is called as adsorbate. Okay, so what is adsorbate? Adsorbate is a particles or something that sitting on the surface of anything. Okay, in this case, it sit on the surface of iron rod. Okay, now iron rod is called adsorbent. Adsorbent. So what is absorbent? Adsorbent is substance at which particle sit on. Okay. Another example is a duster and chalk. Okay, when we erase the chalk at the whiteboard, okay, we can see the particles of chalk sitting on top of the duster. So the chalk particles is adsorbate and duster is adsorbent. So this phenomenon is known as adsorption. Okay. We also has absorption. Okay. You can see the difference here. Absorption and adsorption. This is AD and this is AB. So what is absorption? Example, we have a bowl here that contain water inside and we have sponge. When we dip the sponge in the water, okay, what happened? The sponge will absorb the water. So this is called absorption. The absorption, also known as bulk phenomenon. Bulk, okay, meaning that the particles move into the substance. Okay, now the particles now is H2O, which it move into the sponge. So it is called absorption. Compared to adsorption, it is particles that sit on something. Okay, so the keyword is sit on. Compared to absorption, it is move into. Alright. Other example we have here, let's say a cylinder here that contain water and ink. So ink is a dye. Alright. And we have chalk. Now I dip the chalk into the cylinder. So what happened to the chalk? We can see that on top of the surface of the chalk, there will be a particle of dye and the water is absorbed into the chalk. Alright, so this is called sorption. So what is sorption? Sorption is adsorption and absorption that taking place simultaneously. Okay. And we have another term which is desorption. So desorption is where we remove the particles or the substance that absorb or adsorb on the surface of something. Okay, so you have to understand the term here: adsorption, absorption, sorption, desorption, and you can differentiate what is adsorbate and what is adsorbent. Taking example of iron rod and rust, it is adsorption process. So the adsorption process is a process in which a substance becomes attached to the surface of a solid or liquid. There come the terms adsorbate and absorbent. The adsorption is different with absorption. The absorption is the substance become distributed throughout the solid or liquid. For example, the sponge that absorb water. There are few examples that involve adsorption process. First one is activated charcoal that absorb gases like carbon dioxide, sulfur dioxide, or chlorine. Second one, platinum or nickel metal kept in contact with a gas absorb the gas. This process is called hydrogenation of oils or trans fat. You may search what is trans fat. Number 3, animal charcoal. When the animal charcoal being added into the acetic acid solution and shaken vigorously, it will absorb the acetic acid. And the last one, molasses is decolorized by activated charcoal. There are a few factors that will affect adsorption. First one is nature of the adsorbate and absorbent. Second, the surface area of adsorbent. Third, activation of adsorbent. And last one is experimental condition such as temperature, pressure, and also can be a ratio of the adsorbate and absorbent. Okay, there are two types of adsorption. First one is chemical adsorption and the second one is physical absorption. Listed in the table are the difference of physical adsorption and chemical adsorption. In physical adsorption, there will be multi-layer adsorption occurs, and compared to chemical absorption, the adsorption will lead to a monolayer. What is multi-layer and monolayer adsorption? In monolayer adsorption, all the adsorbed molecules are in contact with the surface layer of the adsorbent. Compared to multi-layer adsorption, the adsorption space accommodates more than one layer of molecules and not all adsorbed molecules are in contact with the surface layer of the adsorbent.